I'm Dara Perrott.
I'm Lizzie Patrick.
I'm Lainie, Edie.
And this is our presentation on plastic to plankton comparisons within the North Atlantic and North Pacific gyres. We measured the ratio of plastic to plankton collected within both gyres, and the ratio showed to be higher in both the day and during the springtime, with higher amounts overall within the Atlantic.
Microplastics are increasing in number within the oceans, which also increases their effect on predators through bioaccumulation and toxin accumulation. So the objectives of our study was to take in the amount of plastic compared to plankton within the environment and measure them in ratios based on temporal and spatial scales. So we specifically did time of day versus time of night and fall versus spring, and then spatially North Atlantic versus North Pacific. Our hypotheses were the North Atlantic and North Pacific gyres will have greater plankton to plastic ratios, and the greatest amount of plastic within the gyres ratios will be within the North Pacific gyre.
And then for our methods, there were over 1,800 tows conducted by the Sea Education Association between 1986 and 2010 within the North Atlantic and North Pacific gyres. Tows were done during both the day and the night within both gyres for the seasons of fall, which we counted as October through November, and spring, which was April through July. Samples were then collected with a 1 meter wide by half a meter tall Newston net with 333 micron mesh, and each tow lasted for about 30 minutes at 2 knots. Plastic was then visually handpicked, and zooplankton larger than 2 centimeters were discarded. Biovolume of the plankton was calculated into mass via equations from Weeb et al., and then a conversion from Morey-Ferguson et al. Was used to calculate the average weight of a single piece of plastic. Finally, both plastic and plankton were converted into grams to obtain mean ratios as accurate as possible. If you look down at the map of our gyres, our latitude and longitude ranges for North Atlantic gyre was defined as 22 degrees to 38 degrees north and 79 degrees west and 54 degrees west. While the ranges for the North Pacific gyre were then defined as 25 degrees to 41 degrees north and 130 to 180 degrees west.
For results, figure 1 depicts the mean plastic to plankton ratio for the day versus the night in both the North Atlantic and the North Pacific gyre, and figure 2 depicts the daytime data of fall versus spring in both the North Atlantic and North Pacific. And overall, in the North Atlantic gyre, there was higher plastic to plankton ratio for daytime data in the daytime versus nighttime data set. We used daytime data for our overall results because it showed the least amount of bias. Zooplankton participate in deal vertical migration. During this, they come to the surface during the night to feed. Nighttime data would show higher zooplankton counts, but it does not affect the microplastic abundance as plastic is not migrating. Using daytime data allowed us to portray a ratio when the plankton would be at its lowest. In the springtime versus fall data set, there was a higher plastic to plankton ratio for the spring data. Zooplankton experienced seasonal variation. Normally, we would expect to see the ratio would be lower in the spring due to spring zooplankton blooms, which would increase the overall zooplankton abundance, but the microplastic would stay relatively the same. In our study, we did not find this to be the case in the North Atlantic gyre. Overall, the North Atlantic gyre had the highest overall daytime and spring data. For the North Pacific gyre, there was a higher plastic to plankton ratio for daytime than in the daytime versus nighttime data set for the same reasons as stated earlier. There was also a lower plastic to plankton ratio for the spring data as expected, but no fall data was collected for the Pacific. It was unexpected that we found the ratio to be the highest overall in the North Atlantic gyre, as the North Pacific gyre is commonly known as the Great Pacific Garbage Patch. Our ratios show that the concentrations of plastic is higher in the Atlantic than in the Pacific. This leads us to believe that there should be more significance placed upon the North Atlantic gyre than there currently is.
Future research also includes filling in the missing data of the fall North Pacific gyre, as well as examining microplastics beyond just the gyres themselves. And finally, hopefully to analyze data by using median to see if it's any different from the mean we collected. Overall, further research to add to our study and findings and greater understand microplastics within the environment. Thank you.